All right, section 4.3 has to do with the remainder and factor theorems of a polynomial. The remainder theorem basically says that if a polynomial is divided by x minus r, the remainder is a constant r, the p of r, and that the polynomial could be derived by the divisor, the answer to your quotient problem, plus the remainder. So I know that's a lot of words, so let me show you what that means in theory. So I'm going to take this and I'm going to divide it by this. Now I'm going to do synthetic division on it. Remember, to do synthetic division, that has to be in an x minus r form, which means my r here is -3. So I'm going to put the -3 out here in my half box. I'm going to do my leading coefficient. So I have 1, 4, -3, and -5. Okay, this is my one leading coefficient, but I'm going to use all the coefficients for each one. So I'm going to bring the 1 straight down. This is synthetic division. Then I'm going to multiply -3 times 1, and then I'm going to place it as -3. Then I'm going to add this. -3 times 1 is -3. When I add those, I get a -6. I'm going to multiply, place, add, and that's going to give me a +13. That 13 is going to be my remainder, if you will. So if I make my other polynomial, then I'm going to do a depressed polynomial. So this started as cubed, so this one's going to start as squared. So I have x squared plus so 1x squared plus the 1x minus 6. And then this right here is the remainder. If I was going to write it in actual polynomial form, I would then turn around and take this, the 13, and I would place it over the divisor, which is an x plus 3. Okay, so if I go to actually divide that, that's the answer. The remainder theorem says if I took that -3, the number that goes out here in my synthetic division, which is the actual zero root or solution to the problem, this is the factor form of it. Then if I plug that in, so if I say the p of -3, and I plug it into this equation, x cubed plus 4x squared minus 3x minus 5. Then when I plug that in, and I would probably use the store button on my calculator to make it easier, the result should be that remainder. So you should, when you plug in this factor, the remainder should be the result of plugging it in. So if I plug this in, I'll do it by hand since I don't have my calculator right here. So everywhere I have an x, I'm going to plug in my -3. So this is going to give me a -27. And this would give me a positive, that would be 9, +36, plus +9 minus 5. So I actually have a negative, when I do that and that together, a -32 plus my 36. Okay, so I just combine my negatives here, plus 9. So this is going to give me a +4 plus 9, which would give me my 13. The same thing that you get over here when you do the remainder. So it's just two different ways of getting the remainder. Now the other part of this remainder theorem says that if I multiply together the x plus 3, the whole part of this, so the x squared plus x minus 6, and then I added the remainder to it, my answer would be my original polynomial. So that's going to be the answer when I multiply this times what I divided it by, and I add the remainder. You could do it like this. This might help you remember it. If I took 5 into 27, 5 goes into 27 5 times with a remainder of 2. So if I went to check this, I could go 5 times 5, and I would add the 2, and it would give me the 27, which is the same thing I have here. You did the same thing here. You go this times this, which is the same thing as multiplying this times this, and then you add the remainder, and that gives you the original polynomial, which is what you're dividing into, just like the 27 is what you're dividing into. So you've got the principle behind this, and you've had that for years. Make sure you can see the whole page here. All right, so I'm going to use synthetic division to solve this problem. It doesn't say anything about finding, using the remainder theorem, but this one says use synthetic division. So I'm going to have a -1 out here on the outside, because remember, this has to be an x minus r form. So this could be an x minus a -1. So therefore your r is your -1. It's going to be just in the opposite sign as what you have here. Now, I use my coefficient, so I have a 1, I have a -1, and then I have nothing here for an x to the first power. So I have to put a placeholder, and then I have my 2. So I'm going to bring my 1 straight down, then I'm going to multiply, place it, add it, multiply, place it, add it, multiply, place it, add it. Now notice the remainder here is 0, because that's the last number I get. So step down or depress polynomial. So if this is cubed, this one has to be squared. So I have an x squared minus a 2x plus a 2. So that would be the answer to this division problem. Now, going back to the remainder theorem, if I multiplied this times this, I would get that, because these two are what we call factors of that. This one says use the remainder theorem to find the remainder when that is divided by that. Well, I'm using the remainder theorem, so all I'm going to do is I'm going to plug in 1. So I'm going to go the f of 1, and I'm plugging it into this equation. So I have, and you can use the store button on your calculator if you want. So this is going to give me a 1, so that's going to give me a 2 here. This is going to give me a 1, so minus 3 plus 1. So that's going to give me a 0 remainder, because I have 2 plus 1 plus a -3. So in other words, this is a factor of that, because I get a remainder of 0. And that's what this next theorem says. The next theorem says the binomial x minus r is a factor of the polynomial p of x if and only if the p of r is equal to 0. In other words, you plug it in and you get 0 as a result. So now we're going to combine what we were doing, and they're just going to ask you for the binomial factors of this. Now you're not asking for the solutions or the roots, but or the zeros, you're asking for the factors. So here, right now, this is a little bit harder, because we don't have a technique that we're going to learn in the next section that's going to help narrow this down. So what we're going to do is we're just going to kind of guess at numbers that might be solutions to it. So we'll start at -3, -2, -1, 0, 1, and 2. And what we're going to do is we're going to plug these into this equation using the store button on our calculator until we find one that works. So let's plug in the -3. I don't have my calculator sitting right here, but I have a -3. I'm going to cube it. -7 times -3 plus 6. So that's going to give me a -27. Plus positive 21 plus 6, which is going to give me a 0. So this right here, I know that this one is a solution, root, or 0 of it. So then I'm going to take that, I'm going to put it in my half a box, and I'm going to do synthetic division on it. So I've got a 1, I would have a 0 for the x squared, I have a -7, and I have a 6. I'm going to bring the 1 straight down. I'm going to get a 1 here, multiply, place, add, multiply, place, add, and indeed I do get a 0 as my remainder. So now I have x squared minus 3x plus 2. So I have that. I know the original is x plus 3 because this is the 0, the root, or the solution, but this is the factor form of it, okay? Now, if you look here, I can keep going. So I have x plus 3, and then I have x minus 2, and an x minus 1 when I factor that. So these right here are the factors of this polynomial. If they ask me for the roots of this polynomial, I would solve these, and I would get negative 3, positive 2, and positive 1. That would be where this polynomial crosses the x-axis. Okay, let's do another one. Okay, again, and let me grab my calculator. Just makes it a whole lot easier when you use your store button on here. So what I'm going to do, again, I'm going to pick some numbers. Now, in the next section, we're going to learn how to narrow in these numbers so they're not just random. So I'm going to take the negative 3, and I'm going to store it for the x, and then I'm going to put that equation in. So I have x raised to the 3rd power minus 2x squared minus 13x minus 10. And I get a negative 16 here, so you know that one doesn't work. I'm going to go back, and I'm going to do a negative 2. The negative 2 works. When I plug that in, I get a 0. So that's where I'm going to start. I'm going to put the negative 2 out here in my half a box. Then I'm going to put my coefficients. Bring the 1 straight down. Place it, add. Place it, add, place it, add, and if you've done it right, then the last one's going to be 0. So the depressed polynomial is x squared minus 4x minus 5. So I know this times x plus 2 is going to give me this polynomial, but I can take this one step further to find the factors of this. Remember, factors are what you multiply together to get it. So I have an x minus 5 and an x plus 1. So these are the factors, what you multiply together to get that polynomial. If they asked me for the roots, which they didn't this time through, it would be negative 2, positive 5, and negative 1. And those would be the roots or the solutions or the zeros of those equations. All right, there's another type of problem that you're going to use this for. You're going to solve for a missing variable using the factor theorem. So find the value of k so that the remainder of this division problem is 0. So I know when I plug in the negative 3 into this equation, x cubed plus 3x squared minus kx minus 24, for this to be a factor, a solution of this, I would have to get 0 as a remainder when I plug it in. So I'm going to go 0 is equal to negative 3 cubed plus 3, and I'm going to plug in again. So now I just have one variable that I can solve for, okay? Because remember, if this right here is a root of this, that when I plug in the negative 3, I should get 0 as the remainder, according to the factor theorem. So this is going to be a negative 27, and this is going to give me a positive 9 times 3, which is a positive 27. This would give me a positive 3k minus 24. Those two cancel out. If I move the 24 over, I have a 3k is equal to 24, or k is equal to 8. Okay, So that is the solution for k. So let's do another one. So again, if I plug in, this time it would be a positive 2 into this equation. Then I should get 0 as an answer. So 2 cubed plus 6 times 2 squared minus j times 2 minus 8. So this is going to give me an 8. This is going to give me, that would be a 4 times 6, which is 24, minus 2j minus 8. So the 8's go away. I'm going to move the 24 over, so I have a negative 24 is equal to negative 2j. And then when I divide, I find out that j is equal to 12. All right, your homework on this is page 226 through 227, 14 through 40 even.